Welcome to the video where I explain regression analysis. In this video we will discuss simple regression, multiple regression. I'll say something about mean centering, why mean centering and how to test for moderation, how to interpret these coefficients, and lastly how to test for mediation. Simple regression is exactly the same as a correlation. It signifies the relationship between two variables. Only in regression you assume that one variable causes the other, and in correlation analysis you do not assume any causation between the two variables. So a correlation coefficient is the same as a standardized coefficient in a simple regression equation. So here I have a data set where each line represents a movie. So as you can see, each movie is represented in the data twice. So if you go you see here that the first line is Germany, the second line is Italy. Each movie has an IMDB rating, has a certain revenue, generated a certain revenue during the opening week, and has been viewed in several screens during the opening week. The screens is the number of cinemas where it has been shown. For each movie we also know the budget. The budget is labeled in millions. So what I would like to do is do the analysis and see whether the revenue, which is the profit that has been made of a movie, here the opening revenues, whether it's related to the budget. So first, to do that, of course, we need to see what we're dealing with. So let's first run the descriptives of the variables. Well, as you can see, the mean is $2020 million in budget. And the mean of the opening revenues, which is in dollars, is $1,840,000. Yeah, so you see that the ranges are very different from the two variables. What we don't see is whether there are outliers. Run a histogram. Well, with the budget in dollars, it seems that a lot of budgets of movies are very small and only a few are very large. So what we're going to do, we're going to regard these outliers as outliers and delete them from the database. As you can see in the graph, they have a higher than, let's say $200,000. So we're going to select all the cases, all the movies that have a smaller budget than 200,000. So if we're going to run the graph again, you will see now that we have a different range. These are all the movies with a budget between 0 and 250, which are now here the lines close to 0. Do the same graph, but then with the dependent variable, the revenues. Well, as you can see, this revenue data is highly skewed. When we transform this variable with a log transformation, it becomes more normal. And actually, since this is the dependent variable, this is very important. If the dependent variable is not normal, the errors are not normal either, and we violate the assumptions of linear regression. So let's transform this variable. Hereby I compute a new variable, log rev. And when I again run this, you see that it is nicely normally distributed. Yeah. So let's run a regression, a simple regression. The dependent variable is log revenue. And we enter the budget variable. Here we have the results. So what does this really mean? First, we look at the unstandardized coefficients. You see that a 1 point increase in the independent variables leads to a 0.013 increase in the dependent variable. So what does it really mean in this case? In this case, it means that an extra $1 million in budget for a movie leads to a 0.013 increase in the log revenue generated by that movie. Now the constant coefficient, it actually signifies the mean level of log revenue for where the budget is 0. Yeah, so the constant variable, a constant always signifies the mean level of the dependent variable where the independent variables are 0, in this case the budget. Now since there is no budget of 0, and most likely, theoretically, this makes no sense to have a budget of $0 for a movie. We're going to discuss how to do this with mean centering. So we're going to take the mean. We're going to compute this new variable, which we call mean budget. And we're going to do the same regression analysis, but now with the mean-centered variable. Now you see that the coefficient is still the same, because a 1 point increase is still the same. However, the constant changes, right? Because previously this was 12.8, but now it becomes 13.6. Now it still is the same, you still have to interpret it in the same way. It's the mean level of log revenue where the independent variable is 0. However, since we detracted the mean of each value in budget, it means that the mean level is now 0. So the constant is now the mean level of log revenue for an average budget. The standardized coefficients, however, those have a different interpretation. There it means that if you go up in 1 standard deviation of budget, you go up in 0.55 in the log revenue. So let's test these assumptions. So here I have the syntax for plotting the residuals. So first we look at the normality. So we see here that, the dependent variable, the residuals, actually the standardized residuals, they relatively follow this normal distribution, right? However, if we plot the residuals with the predicted values, we can actually say something about the independence of this relationship. Well, as you can see, if it would be dependent, if the error would be dependent on the predicted value, you would have still something to be explained in your data, and you need to add more variables to your model. In this case, we do not really see a clear linear pattern or maybe a quadratic pattern. It doesn't appear. What we do see is a violation of homoscedasticity, which we will treat a little bit later in this video. So let's move on to multiple regression. How does it differ from simple regression, where you actually add like multiple variables, independent variables, to your model? So let's add another variable to our model. Let's add the rating. First gonna do the not mean centered values. So here we have the results. If we look at the coefficients, we see that one increase in budget, meaning $1 extra million, leads to a 0.013 increase in log revenue. However, since we have included two variables, now this coefficient actually means an increase in the budget of $1 million, holding the rating constant. So for each level of the rating, a 1 point increase in dollars leads to a 0.013 increase in log revenue. And the other way around, a 1 point increase in rating leads to a 0.073 increase in log revenue for all levels of an increase in budget. So holding the budget constant. Yeah, this is the ceteris paribus rule. Is where you include several variables in your equation. It means that the effect of one variable signifies an increase in that variable, holding the other variables constant. Of the IMDB rating. Nice. And let's add it here to the model. So now we have the results for the mean-centered multiple regression. Now the 1 point increase, well, as you can see, the coefficients are still the same. A 1 point increase is not different for a mean-centered variable than for an original variable. A 1 point increase is still a 1 point increase. However, the meaning of the constant is different. So this constant now represents the mean level of log revenue for where the independent variables are 0. So in this case, that means it is the mean level of log revenue for an average budget and an average rating. Now, if we can compare this to the previous results, we see that a constant has changed. Because in this case, where it's still the original value of the variables, the constant signifies the mean level of log revenue for when the budget is 0 and the rating is 0. Now remember again, this 0 does not have a meaning because the budget there is no movie with a budget of $0 and there's no movie with a rating of 0. Therefore, we use this mean centering, meaning that now the constant has a meaning. It is the average level of revenue for a movie with an average rating and an average budget. And similarly to the previous equation, we say that a 1 point increase in budget leads to a 0.013 increase in log revenue, holding the rating constant. And similarly, a 1 point increase in rating leads to a 0.07 increase in log revenue, holding the budget constant. Now let me do this mean centering in an alternative way, where we just want to distract the lowest value, right? So then the constant represents the mean level of log revenue for the lowest value of a rating and the movie budget. So again, the lowest value is 1.6. We call it low, and we do the same for budget. Again, we also have to look what is the lowest value. It's 2. So we're gonna run a regression analysis with these low values. So now you see again a 1 point increase leads to a similar effect in revenue. That does not change, but the intercept now changes. The intercept now represents the mean log revenue for a movie, a hypothetical movie with the low budget, the lowest budget possible, $2 million, and the lowest rating, which is the 1.6 rating. Yeah. So if you distract the number, that becomes 0. Now this budget and rating, of course, a 1 point increase in rating means something else than a 1 point increase in budget. As we already saw, budget runs from 2 to 250. while rating only runs from 1.6 to 8.8, meaning that a 1 point increase in rating actually means something more, it means something else than a 1 point increase in budget. And therefore these unstandardized coefficients are very difficult to be compared. And you cannot say based on these coefficients that rating has a stronger effect than budget, because a 1 point increase in rating simply means something more than a 1 point increase in budget, as budget runs from 2 to 250. So therefore we need to look at the standardized coefficients. Now the standardized coefficients, they actually show what it means if rating would increase with 1 standard deviation. If it would increase with 1 standard deviation, the log revenue would increase with 0.05. If the budget would increase with 1 standard deviation, the revenue would increase with 0.546. So now you can actually compare them, because now the increase is labeled in terms of standard deviations instead of points. So if one would increase in 1 standard deviation, you would actually get, the budget leads to a much greater, higher revenue than rating. So let's look at the last pick. So here we test the assumptions both of independence and homoscedasticity. So as we can see, the residual is related to the predicted value. For low values of the predicted value, you actually see a large range of residuals. So these points are the movies, right? For each movie level, there is a different residual. So for instance, this point, actually, the predicted value, the model does not explain a lot because the residual is very large. However, for these movies that are labeled here, the model explains a lot, because apparently the residual is 0. And again, so you can see that the range of the residuals is very large for the predicted values that are low. But the higher the predicted values get, the lower the variance among the residuals. So this points to homoscedasticity. Now, since we have multiple independent variables, we don't really know what causes this homoscedasticity. So in order to explore that, we should make a scatter plot of different variables. So for instance, I'm not sure if this is... So now we use the M budget, right? The mean-centered budget. We could also use the normal budget, it doesn't really matter. So you see that now the budget, it starts -50, meaning, these are the actual values of 2 million, right? That was the lowest budget. And this was actually 250, but we distracted the mean, which was 60. So now the 2 becomes smaller than -50, and the 250 becomes now smaller than 200. As you can see, the variance of the residual is larger for lower values of budget. So the higher the budget gets, the better the model can explain the variance, and the lower the residual becomes. Now let's see if we see a similar picture for rating. So here you see that for rating this is actually not the case. So here we see a cloud. So basically for different levels of rating, the residual is not really different. Yeah, the variance is relatively the same. So now we know that the homoscedasticity that was shown in the first graph with the predicted value is completely caused by the budget. So please go to my next video to hear more about moderation and mediation.